Maxima and minima part 2. Second derivative test. Working rule. Find first derivative, put it equal to 0 and get the value of x. Then find second derivative and now check the sign of second derivative at this point. If it is positive, then function will be minimum. If it is negative, then function will be maximum. And if it is 0, then this test will fail. More specifically, we can state a theorem. Let f be a function defined on an interval I and c belongs to I. Let f be twice differentiable at c. Then x equal to c is a point of local maximum if f dash c equal to 0 and f double dash c is less than 0. The value of x, the value of c is local maximum value of f. X equal to c is a point of local minimum if f dash c equal to 0 and f double dash c is greater than 0. In this case, fc is a local minimum value of f. The test fails if f dash c equal to 0 and f double dash c equal to 0. In this case, we try the first derivative test and then we try to locate local maximum, local minimum, or point of inflection. Now, let's understand it by some questions. Question number 1. Find two positive numbers whose sum is 15 and the sum of whose square is minimum. So, we write x plus y equal to 15 from where y equal to 15 minus x. Sum of whose squares is minimum. So suppose we write it s and then x square plus y square. This is to be minimized. So s equal to x square plus in place of y we write 15 minus x whole square. Now we differentiate it. ds upon dx will give 2x plus twice of 15 minus x times minus 1. We put ds upon dx equal to 0. So we get 2x equal to 2 into 15 minus 2x or 4x equal to 30 from where x equal to 7.5. And if we put this value of x here, so we get y is also as 7.5. Now we find second derivative d2s by dx2. Second derivative, if we differentiate it, it will become 2. And if we differentiate it, it will give 2 into minus 1 into minus 1 from here. So which will be greater than 0. Hence function will be minimum. And the corresponding values of x and y are 7.5 and 7.5. Now consider next question. What is the maximum value of the function sine x plus cos x? Let's write it as y equal to sine x plus cos x. We differentiate it. dy by dx equals cos x minus sine x. We put it equal to 0. dy by dx equal to 0. That is cos x minus sine x equal to 0. From where we get sine x equal to cos x implies tan x. We are dividing by cos x. Tan x equal to 1 or x equal to 5 by 4. Now we try second derivative. d2 by dx2, that will be minus sine x minus cos x. So when we put this value of x here, so we get d2y by dx2 less than 0. Hence function is maximum and the maximum value can be found by putting value of x here. So f pi by 4 will be sine pi by 4 plus cos pi by 4. And that will be equal to 1 upon root 2 plus 1 upon root 2, that is 2 upon root 2, which is equal to root 2. Now let's go to next question. Find two numbers whose sum is 24 and whose product is as large as possible. So x plus y equal to 24, from where we get y equal to 24 minus x, and let's denote product as p. So p equal to xy, so that is equal to x times 24 minus x, or 24x minus x square. We find dp upon dx. That will be 24 minus 2x. We put dp upon dx equal to 0. So 2x equal to 24 from where x equal to 12. When x equal to 12, y will also be 12. Now we try second derivative. So d2p by dx2, that will be equal to minus 2, which is less than 0, and function is maximum. So corresponding values of x and y are 12 and 12. Consider next question. Find two positive numbers xy such that x plus y equal to 60 and xy cube is maximum. So x plus y equal to 60, from where we get y equal to 60 minus x. Then we denote xy cube as p. So this gives p equal to x times y is 60 minus x whole cube. We differentiate it dp upon dx. Apply product rule. Differentiation of first will give 1, second will remain intact. Now we differentiate second 3 times 60 minus x whole square into minus 1 times x. Now we put first derivative equal to 0, dp upon dx equal to 0. So this will give from here 60 minus x whole square, we can take common, then we will be left with 60 minus x, and from here minus 3x equal to 0. So x can't be 60, so 60 equal to 4x, from where x equal to 15. Then y will be 45. Now we find second derivative. So we have dp upon dx equal to 60 minus 4x times 60 minus x whole square. So d2p by dx2 will be, first we differentiate this term, so that will give minus 4, and second term will remain intact, 60 minus x whole square. Now we differentiate this term, so this will become twice of 60 minus x into minus 1, and second term, this term will remain intact, 60 minus 4x. When we put x equal to 15, we get d2p by dx2 negative, that is less than 0, hence function is maximum. Now let's consider next question. Find two positive numbers whose sum is 16 and sum of whose cubes is minimum. So x plus y equal to 16, and sum of whose cubes. So we write s as x cube plus y cube, and this is to be minimized. From here y equal to 16 minus x, so s will be equal to x cube plus 16 minus x whole cube. Now we differentiate ds by, differentiate this s, ds by dx will be equal to, differentiation of this will become 3x square, and differentiation of this will become 3 times 16 minus x whole square times minus 1. Now we put ds upon dx equal to 0. So this will give 3x square minus 3 times 16 minus x whole square equal to 0, or 3x square equal to 3 times 16 minus x whole square. 3 will cancel out. So we take square root. So x equal to, we write in reverse way, 16 minus x whole square equal to x square, which gives 16 minus x equal to plus minus x. So here we have to choose only x as positive, otherwise it will become 0. So 2x equal to 16, from where we get x equal to 8. So when x equal to 8, y will also be 8. Now we try second derivative, d2s by dx2, which will be equal to, it will become 6x minus 3 times derivative of this will be twice of 16 minus x times minus 1. So 6x plus 6 times 16 minus x. Now, at x equal to 8, this value will be positive. 6 into 8 plus 6 times 8, which is greater than 0. Hence, function is minimum. Thank you for watching.